The world feels pretty solid under our feet, right? The continents, they seem so massive, so permanent. But what if I told you that deep below the surface, these unseen forces are constantly at work? They're squeezing, stretching, and literally reshaping our planet in ways we're only just starting to wrap our heads around. So let's dive right in.
Okay, think about a place like Australia. You don't really picture megavolcanoes or huge fault lines, right? It feels like the safest place on Earth, geologically speaking, like a solid, unbreakable shield. But, well, that feeling of safety, turns out it might just be an illusion.
Yeah, because the latest research, it suggests that under that super calm exterior, Australia is quietly building up a ton of energy. Just imagine holding a plastic ruler, and you just keep bending it and bending it. You know it's going to happen, right? Eventually, it's got to snap.
And that right there brings us to this bigger idea we really need to look at, the whole myth of a stable continent.
So we all remember learning about tectonic plates in school, right? These giant floating puzzle pieces that make up the Earth's crust. And we know that where they smash and grind against each other, that's where all the action is. The earthquakes, the volcanoes. That's the story we're all taught. But it's really only half the story.
See, here's the really crucial part. That stress, it doesn't just stop at the plate edges. Nope, it travels, radiating, deep into the heart of the continents themselves. Think of it like a giant sheet of ice. If you squeeze it from both sides, the pressure isn't just felt at the very edge, right? It spreads all the way through.
Okay, so how on earth do you even see this invisible pressure? Well, scientists have put together something pretty extraordinary, what is basically a hidden stress map of the entire planet.
And look, this isn't just some theory or a computer model. We're talking about researchers compiling data from more than 100,000 real-world measurements. I mean, from rock tests, oil wells, earthquake data, all of it, just to build the most detailed picture we have ever had of where our planet is being squeezed the hardest.
And when they put all that data together, the result was, honestly, it was stunning. The map just lit up with these high-stress zones. And to the absolute shock of pretty much everyone, one of the most stressed out places on the entire globe was Australia. The one place everyone thought was totally safe.
So, what's going on here? Why is Australia so stressed out? I mean, it sits really far from all the action at the plate boundaries, so it should be pretty chill. But instead, it's caught in this kind of continental vice. You've got the massive Pacific and Eurasian plates squeezing it from different directions. And since there are no big fault lines to let off steam, that pressure just has nowhere to go. It just builds and builds and builds.
And at some spots, like Australia's Bowen Basin, it gets even crazier. The stress fields aren't just pushing, they're actually twisting and rotating. And that is incredibly dangerous. Why? Because that kind of unpredictable stress behaves, as one scientist put it, like glass about to shatter. You have no idea when or where the first crack is going to appear. Now, this whole idea of a continent breaking apart from the inside out, it isn't just a theory based on some fancy maps. We can actually see it happening in the real world, right now. For that, we've got to head over to Africa.
So, okay, if Australia is all about compression, being squeezed, then Africa is the perfect example of the exact opposite, tension. This is a continent that is literally being pulled apart at the seams.
What you're looking at is the East African Rift System. It's this gigantic tear, a scar on the Earth's crust, that runs for thousands of miles. And it's probably the clearest evidence we have anywhere on the planet that Africa isn't one solid continent anymore. It's actively unzipping itself into two brand new pieces, the Nubian Plate and the Somalian Plate.
Now, the speed of this split is almost comically slow. We're talking less than an inch a year. That's about how fast your fingernails grow. So yeah, you're not going to feel it. But on a geological clock, that is lightning fast.
And the timeline here is just mind-boggling. This whole process kicked off about 25 million years ago. But let's fast forward into the future, say 5 to 10 million years from now. The continent could stretch so thin that the ocean just rushes in, creating a brand new sea and literally tearing East Africa away from the mainland.
So that begs a pretty big question, right? If this stuff happens so slowly, how do scientists even measure it? Well, the answer, believe it or not, is hidden inside ancient lava.
So let's pivot to another geological hotspot, Turkey. This place is wild. It's sitting right at the collision point of three major plates, the Arabian, Eurasian, and African. I mean, the stress map here is just screaming danger. which for scientists makes it the perfect place to study. So researchers there came up with this really brilliant method. First, they looked at ancient lava flows right near a massive fault. Inside that lava, they found these microscopic little crystals called zircons, which act like tiny geological stopwatches. See, by measuring the helium gas trapped inside these crystals, they can figure out exactly when that lava cooled and hardened. So then, they can compare that age to how much the rock has stretched since then, and boom, you can calculate the exact speed of the split. And what they found was huge. The fault wasn't just sliding past itself. It was literally ripping open. The evidence was just undeniable. You could see that lava, which once flowed as one single smooth sheet, had been pulled apart over millions of years. The image was so clear that they described it as looking like a snapped chocolate bar. You can just perfectly picture how the two broken pieces once fit together.
So, okay, this is all fascinating science, but it's more than just a cool geology lesson. This has some really profound implications for how we live on this planet. It's forcing us to completely rewrite our entire understanding of risk.
I mean, this global stress map, it's not just for academics. It's a real practical tool for our own safety. It can help us pinpoint future risk zones long before something catastrophic happens. It tells engineers where it's safer to drill for resources, or maybe, more importantly, where you absolutely should not build a tunnel. It can even help us figure out which bridges and dams need to be reinforced. What it really proves is that our whole idea of a geologically safe place, well, that might be totally outdated. But here's the big catch. There's a massive piece of this puzzle that's still missing. This incredible map. It can show us exactly where the tension is building up with amazing accuracy. But the one thing it can't tell us is when it's all going to give. And that leaves us with a pretty humbling thought, doesn't it? You and I, we look at a world map and we see something permanent, something fixed. But the Earth, it's a living, breathing thing. It never, ever stops changing. It just operates on a timescale that is so huge, it's hard for our brains to even comprehend. So it makes you wonder, if this is what our map looks like today, what's it going to look like in 10 million years, after these unseen forces have had their way with it?